Okay. Are you people are able to hear the voice? Roll number 2? Yes, 2?
Yes, ma'am.
Okay. We start the lab. Before that, we know about the microcontroller which we are going to use it. Okay, in our lab, we are using with the family Atmel. Okay, ATMEL. Okay, with this Atmel family 89 version series 51 will be using it. Okay, so in this one, this actually manufacturing the Atmel company. It's based on American manufacturer semiconductor device. It is okay, and in this one we are writing it EPROM and flash memory devices will be using it in this one. Okay, and we use it here relays, keypad, switches also. Okay, so we do it everything in a Keel version. Okay, we had the n number of versions are available on your website. We are going to use it here. It is. Keel version 5 we are using it. Okay, right now I'm using Keel version 5. You can use it 3 or 4, anything. Okay, for basic programming. Okay, now before we start this one, I'll share the screen so you'll understand it what we are doing it here. Okay, so write down the steps, all of you. Okay, okay, we start with the Keel version 5. Okay, see here. Before start this, you create one folder with the name of switch and LED. Whenever I'm pressing it switch, the LED should glow. Okay. See, as you people know that 8051 architecture will be having it 4 ports, right? Port 0, port 1, port 2, and port 3. Okay. Port 0 is going to have 8 bits. Port 1 is again having 8 bits. Port 2 is again having 8 bits. Okay. Overall, for 8 is 32 bits. Okay. Now here I'm taking it, creating a new folder with the switch interfacing with LED. Okay. So I'm writing it switch LED here. Okay. Creating one, this is a first step. Okay, create your folder with switch and LED. Okay, again here you open it, Keel version 5. So you can see here Keel micro version 5. I'm opening it. So the earlier one, I'll first close it this. Just wait. Okay, just wait. What the problem is? I'll create once again. Okay, here I'm using it. First step, you have to create the folder on the desktop or anywhere. So I'm creating on the desktop. Okay, then again project, new microvision project. Okay, now there I have created a project name is on the desktop. I have created as, what did I created over there? The desktop just now, switch LED, right? Where is the switch LED? I have to press that. Okay, see, switch LED I have taken here. So I'll open it that. Okay, I'll save the file content as switch LED. Okay, same name I'm writing it over here. Write down the steps simultaneously on your observation book. I'm going to check it out that. Okay. After this, the next step is it will ask you like this: select device for target one. Okay, you have to select the device. Now see here, device I'm taking it here. It is RTE. You can see here RTE is I'm selecting it. Now in this tool set, I'm using it AT. AT stands for Atwell. Okay, the company name which I'm selecting it for my microcontroller which I'm going to run on it. Okay, 89. Okay, C51 series. Now you can see that microchip over here. Press it that one. Okay, 89 C51 and say it here. It is okay. Say yes to this. Yes, you have to say, okay, add the files to this content, yes. Now before this, you have to write your program, right? So I'm using it file, new. Okay, now my switch and LED program is basically, whenever I'm pressing my switch, the LED should glow, okay? When I'm switching off my LED, the LED should not glow, right? On and off, it should blink. And I'm having it here. I said already in the first class that we had the 4 ports, remember, right? So 4 ports, we are going to use it here, right? So I'm writing it here, the header file, basic C language only I'm using it here, okay? I'll write it the program as hash include register. Now reg is the register which is having x, which is having 51 is the series. Okay, I'm calling that header file. Okay, next what I'm having it, I'm defining the switch and LED because whenever I press the switch, the LED should glow, right? So here I'm defining two things, that is first one is switch. Okay, so or I'm taking it first LED. So hash define LED, okay, which I'm taking it here P0, okay, 0 first pin P0, okay. Now I'll take it one more. I'll remove the cap now. Hash define, here I'll take it switch, okay. Switch I'm writing with the capital letters because this is hash define values. So here I'm writing P1. Okay, so P1 I'm initiate, P0 I'm initiating, P1 I'm initiating. See, according to you, we can initiate any port numbers. Okay, I had 4 port numbers. I had already explained, right? So in this one, I'm using P0 and P1. So P0.0, P0.1, P0.2, like that it's gone on till 8. Okay, the same thing for P1 also. Okay, till here it is clear, I hope so. Now I'm making it the main program here. So I'll write it int. Now I'll start with the int main. Okay, now when I'm calling the int, it should return the value, so that is why I'm writing here void. Okay, now here in this one I'm using it to LEDs. Okay, LED. Okay, it start from basic 0 hexadecimal value of 00. Just enter these two people who are waiting it. Okay. Now see, I'm taking it, the first basic value is this way. Okay. Now in this one, you will be initializing your LED as the output port. Here it is, LED is your output port, right? Switch is your input port, right? Write down that. Switch is input port, LED is the output port. Now when LED is in your output port, whenever you are pressing 0 cross 0 0, the first state it is. Okay. Now initiate that with while the condition is whenever I press the this one, switch is pressed, LED should glow. That is the condition, right? So I'm writing the while condition here. Okay, while one. Okay, simple here, C language only here. We write it in a embedded C, that's it. Here I'm writing it LED. Okay, we are using tilt. You can see that in your keyboard. We had it before one. This word we call it as tilt. Okay, just we had like negation type. You can check in your keyboards, it will be there. Negation. Okay, that you have to press it. Means negation is nothing but for all. For all. Okay, for LED, whatever the pins you have assigned, for all it is. That means negation is here. Okay. Now that is equal to switch. SWIPCH. Okay, which we have defined it now. We limited here colon, then again close it this. Okay, any doubts still here? Here in this programming, any doubts? Any doubts?
No, ma'am.
No,
Okay,
ma'am.
clear here. Okay, we are making an interface between switch and LED by using Keli version 5. Okay, now here the first step we have done, selecting into the database that microchip, that is over. After that we have to add this file, right? So before this, write down the next step, save the content. Okay, I'm saving the content as SWI, like small letters only I'll write because switch LED, okay, with .c extension because I'm writing in a C. Okay, save this file content. Okay, after this, go to the target here. Okay, target, in this one, options will be there. Options for target one. Okay, here you have to. I said in the morning class regarding the Oslo, this oscillator, remember oscillator, I said something, we had it oscillator I said, right? The reset button, oscillator button, right? So here also we had it the oscillator button. We generally use it for 80, 89, S52, S51 is 11 megahertz of frequency, we use it 11.059. This is common for all your programs. Okay, now in this one, you have to change that. Next device, this is already selected here, 89C51 from the big initial one. Now here, output is there, just press that one menu. In this one output, you press it here, create hexa file. You have to create the hexa file so that your programming should be converted in a hexa, right? And if you get the output, right? Next is debug, not required anything. Utility is also not required. Okay, till here you make it everything things. First thing, device, check it, 8089 S51, C51 should be there. Target, change this megahertz. Next in output, select this, create hexa file. Okay, this is very, this things if it is there, then you can able to execute your program. Say it okay to this. After this, now go to this part, source group, go to this source group here, right click on it and say the here it is add new existing file. Okay, existing file is this one. Okay, switch LED, which is .c file, you have to add it to this target. So add it here and then close it here. So you just press this one plus button, you can see that that file is added here. Now you get three this compilers, you see here. First one is, we had three compilers here. Okay, compile, for linking, and then binding. Okay, rebuild all those things. Okay, so first I'm linking it. See, if you get it any error like this, you will get it here. P0, P1, 6 and 9. You just write it here. Okay, save it once again. Wait, this is 0.
Ma'am, mail is not closed.
Yes. Yes, yes, correct. Main is not closed. Still, it is showing any error. regx 51. Yeah, yeah. Header file it is .h. I forgot. Save it. This one. Okay. See header file I forgot here. .h in this column. Closing loop. Okay. Now P0 and P1 are initiated here. You can just check that header file should be added here. Okay. Now three compilers we have to press it. First will be a programming will be errors will be checked. Second one, your hexa file should be created. Hexa file. I just selected here, right, in the options one. The second one I have selected as hexa. This should be created. Okay, which you are going to burn on your IC. Okay. Second, last one is rebuild all the things. You are rebuilding all the things here. Yeah, third one compiler. Okay, after making it this one, you go to the d is at the back here, debugging session it is. So when I press it debug here, so it will ask for evaluation mode. Yes, you say okay for it. Okay, so it will be showing it like this for step by wise. Now we had it first one, what we had peripherals. You can check here, peripherals will be there here. Which port we am using it over here? P0 and P1, right? P0 I'll take it here and initiate it with P0. What I'm having LED P0, that is equal to 0 0 x 0 0. Okay, when I'm changing this, so you press it here, run button. Okay, whenever I'm pressing any button here, the LED should be going to be glow over there. Okay, pin. Okay, same thing when I'm using it the other port, that is your P1 port. Now here I'm taking it as pressing this, that will go. See, this I'm pressing it, it will go. 0, I'm pressing it 0. Now here, your switch I'm pressing it here. So that LED it is glowing here with the right button. You can check that. See, if I'm pressing it now, this part, see that will be removed. Again, this bit I'm using it, removed. On and off button with this. Okay, got it this? Clear with this? Once you have done this one, take the snap of this output. Okay, this we have done in a software part. Same thing you have to do it in a hardware part also. Come out from the debug session. It will come out like this. Okay, so once the hexa file has been created in your file, you just check that hexa file is created in your file or not. You see, on the desktop we had the file is this. Check here. So here you will be having it listing. The files will be created. Here also obj, here hexa file is created. You can see here .hex. So this hexa file has to be dumped to your hardware device. So how we are going to dump into hardware device? We use it here. One network stimulator we use it here. That is NSTL89SXX ISP. This is showing not connected because it is in a checking mode only. I have not connected to a hardware device here yet. Okay. Once you'll come to the college, I'll show you how it is going to be connected. Okay. Once you press this one, it will say that COM. COM is nothing but your serial COM port has been connected. It will say here. Okay. So first you have to send. Sending in that one option, you have to get the browser. There you have to say that .hex file of switch LED dump. Send. So that will be going to be burned on your IC. Okay, this is your basic software and the hardware execution of your embedded applications. Okay, till now we have done the switch and LED. That hard software also we have checked. Okay, and the hardware, when we connect to the hardware part, the component .hexa file have to burn on that. Okay, and you have to make the connection to switch and LED. One single wire will be there. You have to connect it that. Okay, is it clear? Any doubts in that one? Okay, see, if we are taking it old kit, then you have to use it this NSTL. Okay, if you are taking it the latest one, we had Flash Magic. Okay, this one we have to say select here. Now here I'm using it the select device. I'm using it here, which one? 8089 S52. Okay, so go to this one, 8089 S52 S50 C51, and say it okay for it. So that file will be going to be checked. Okay, this hexa file you have to select it that from the desktop where you have saved it. Okay, now in this one I'm having switched and LED. So go to the switch and LED here. In this one, go to the listing, sorry, in the objects we had it. Okay, just go back. In the object, this hexa file you have to open, and after this you will be having it start button. If you press it, it will show all these things, tick mark are there, no? It will going to get it. After that, that will be burn on your IC. Okay, that you will be knowing it when you are coming to your labs. Okay, till here also, if you show me the execution, the half part has been executed. Which half part? This part, the debugging session, whatever you have done, that thing. Got it? This one, any doubts in this one? Two. Okay, first you install this one software, you'll understand. Okay, 7.
Yes, ma'am.
Okay, is it clear with it?
Yes, ma'am.
Okay, if can I change this port numbers 2 and 3, P2 and P3, 33?
Yes, ma'am.
Can be changed to P2 and P3 also?
Yes.
Okay, any doubts in this one? 35, are you there?
Yes, ma'am.
Any doubts in this?
No doubts, ma'am.
No? See, it will be once you install this one, this is available. Okay, online it is available. It will not take that much of data byte for this one. You can just install it that, and you can check it. Okay, size of your this. Okay, now we go for the next one. See, similarly, I'm using it the relay program. See, relay program is nothing but I'm taking it. A sound will be going to be relay sound will be going to get it when you will be going to heard that one sound when you come to the lab sessions. So we had the same program written over here for relay. See, I'm opening that program here. I have written already. See, this is a program. Same thing, you have to use it. File, new project. Okay. Again, in target, options for target, you have to change here this one, and the chip you have selected 8089 C51. Same thing. Output hexa you have to create it and say it okay for this. Okay, and you have to add this file. Okay, r.c I have taken. In that I have add all this hexa.h file. Okay, now here I'm taking 3 relays, P2 underscore 4, P2 underscore 5, P2 underscore 6, 4, 5, 6. Okay, so this one on and off should be going to be done, right? Relay should be there. Okay, so same thing, it will be taking it for relay 1 when it is 1. Okay, delay for 1 second, 1 microsecond. After that, relay of 1, same relay 1 will be off. Okay, same thing, relay 2, on and off, on and off. Delay I'm using it, that's why delay program I have written here. Void delay unsigned in D. Okay, for how many milliseconds of this one? 1000. For I and J, for I and J, this will be loop will be continued. Okay, now see, in this one, same thing, I'm taking it with the debug session of evaluation sheet. Now going to the peripherals, press it here, IO port. Okay. Now port 2 I have taken here. Yes, 2 of what are that things I am using? 4, 5, 7. So before that I have to change this 0x00. Okay, now I'm changing that one. The pins have to check it out here. It is. But here run button will be there. You just check here that run button. If you press, you'll get the output. Delay with that, you get the output. Same thing of your first one also. We press the same thing. Run button. This run button. Okay, reset button means come back. Okay, so how it is moving out, it will be showing in this programming. Okay, with assembly language. Okay, clear this one, all of you? Okay, now we have to move it out means debug, you close it here, we'll come it out back of this. Press this one, we got it. Okay, is it clear? I don't know how many people are there. Yes, you people are able to hear the voice? Yes,
Yes,
you got the output. This one you understood? Relay, you people have understood?
yes, ma'am.
Okay, so we have done with the two programs, right? Now we had it. First one we did switch and LED. Whenever the switch is pressed, LED will be glowing it, right? Second program, relay will be going to be there. Alternately, 3, 4, 5, 6 pins will be glowing it. Okay, same thing in your hardware device. 4, 5, 6, whatever the relay is there, the sound will be going to be big. Okay, in a buzzer, we use it the same program. And then the half program over there. We do the same thing with the buzzer. So I've written here we use it. You can check that. Okay. Open this one. Buzzer 2 underscore 7. So port 2 I'm using it pin 7. Okay. I'll just add it here. I'll remove it this relay. In place of relay, I'll write it buzzer. We use it this one. Till here I'll remove it. Okay. Simple C it is. So it's not that much complicated one it is. You can check this in your, install this one software, check it out, your outputs with your programs, okay? Browser, okay, 0 and 1, okay? The delay for 1 millisecond. Nice. Now here, same thing, delay program I have written here for subroutine, calling this one, okay? Save this content, same P2 used here, okay? Save this content. After this, go to the source group. First, we'll check the target, whether it is written. It's not written, just change it that, okay? So here I'm using it, 11.059 is the frequency of oscilloscope. 8089S51, it is already selected. Create hexa file, say okay here. After this, go to this button here, add the first save this content and go to this one, add existing file. This is there, .c file, okay? Add and close it. Once it is added here, you can check here. Now these three compilers you have to check out, okay? Hexa is created, then linker is created, okay? hexa linker compiler. Okay, now once this has been done, we go to the D button, debugging button, go to the evaluation mode, say it okay to this. Okay, now we are using in the peripheral of the IO port. Which port I'm using it here? P2 of pin 7 I'm using. So I'm first I'll take it here, it is 00. Okay, and then I'll change it that, go to this one. So 7 is initiated, you can see that. Okay, 80, pin name is 80. You can able to see that, the output. Yes, 2, 7. Clear with this? This run button have to press it. Okay. This is your software execution. Hardware execution, once you will come to the college, I'll explain it how you have to just dump your hexa file. Hexa file will be created. You just burn that one in a IC. That's it. And you have to make the connection to this microcontroller port number to P2 underscore the 7 to buzzer. So you'll get one sound, buzzer sound. You'll be getting it. Okay. Okay. How you people are getting it? 33?
Yes, ma'am.
Okay. 35?
Yes, ma'am.
Okay. These three programs, you people are clear with it today. We have completed switch and LED, relay, buzzer. Okay. Next class, we'll be going to know about mode counters. Very small programs are there. Initially, this we had actually 3 cycles are there in this one. Okay. Cycle 1, 2, 3. Okay, so cycle 1 we had the list of programs are there here. Okay, 12 or 18 are there. Second cycle we had 2 programs. Again, third cycle we had 7 programs. So first cycle only we had 18 programs. So in that we have completed only 3. Okay, see if it is disconnected, just rejoin it so that we can complete again the mode 3 programs. Very simple programs are there. Okay, mode 4 counter, 8 counter and 10 counter. Okay, mode 4 is nothing but 4 connected to your this one. You're getting it in a segment 0, 1, 2, 3. Okay. Okay, otherwise I'll continue in the next class. Okay, just clear with this 3 programs. Is clear all of you with it?
Yes, ma'am.
Okay, I'll just take the attendance. In the next lab, I'll start that part. Okay. Madam Bulare. Are you? Okay. Okay, give your attendance. Just answer your attendance, ma'am. Yes.
Roll number 7.
7,
Roll number 9.
9,
Roll number 10.
10,
Roll number 11.
11,
Roll number 13.
13,
Roll number 33.
33,
29.
29. You are getting it. What are the programs we have done today?
Somewhat.
What, somewhat, ma?
Not perfect.
What you didn't get it, just tell me. 29? Yes, 29. 42, are you there? 42?
Yes, ma'am.
Understood today's lab?
Yes, ma'am, mostly.
See, somewhat this thing you don't tell me like that. Install the software, next lab onwards. Install it and then do these 3 programs. Okay. You'll understand it. Okay, what you're doing it, the basic C language only. Just you're calling the ports. Okay, 4 ports. In that pins you're calling it. That's it. You can creating the hexa file. Is that clear?
Yes, ma'am.
Okay, 17
Okay,
batch
ma'am.
58. 17
Yes,
batch.
ma'am. Present.
Yes, 58. You are clear with this lab session? Yes,
Yes, ma'am.
clear with the lab session?
Yes, ma'am.
16 batch 60. Are you
Yes,
there?
ma'am. Yes, ma'am.
You understood this today's class? Lab?
Yes, ma'am. Yes,
See,
ma'am.
install the software and then try practice these programs. Okay.
Yes, ma'am.
Simply, if you people are going to execute till hardware, it doesn't work out. Okay, you have to simultaneously execute the hardware also. Is that clear?
Yes,
Whenever
ma'am.
you are
Yes, ma'am.
coming to the college, I'll show you the hardware part. Just this is your software part. Till here, you have to execute it. Okay.
Okay, ma'am.
Okay,
Okay.
embedded system is an in between executing between the hardware and the software components. That's what it is called it as. Okay.
How to download the software, ma'am?
Online it is available, ma. Online you just see that free download Keel version 5, Keil. Keel, mu you write it, you write it version 5. Or if you are not finding 5, you can use it 4 also. Same steps. Okay. Fine, ma. Is it clear, ma? All of you?
Ma'am, 35.
Yes, ma'am.
Uh, yes, 35. बोलिए.
Attendance, ma'am.
Yeah, I'm given. 29. 29.
Yes, ma'am.
What you didn't understand today's class? How many programs we have done today?
3, ma'am.
3. So what you have not understood? You tell me that. You first install the this one. So this one, I'll just send you the programs to you people. Simultaneously
Okay.
execute it. Okay. Simply, if you are saying not understanding, what I can do it for it. Okay. Tell me. First execute your programs and then next class if you are getting any errors, you can just clarify that. Okay. Okay, all of you.
Okay.
Okay, we can leave the session.
Ma'am, 301.
Yeah, I've given my attendance 301, 303. You can leave. Okay, I'll send the record also. That initial part, what to be written, I'll just send it that also.